Hello everyone. Today we're going to talk about critiques of LLMs. Let's go back to early 2023, a time when ChatGPT, GPT-4, and Bing Chat were generating intense public excitement. Headlines declared that AGI, artificial general intelligence, was imminent. Why? Because these models were passing exams, the bar exam, coding interview, even the USMLE for doctors. The public took that as proof of real intelligence. But here's the key question. Does passing exams means a machine can truly think like a human? Many assume so, but this assumption is deeply flawed. Exams test stored knowledge and familiar problems patterns, but intelligence is about generating to new unfamiliar situations. Today, we'll unpack this distinction. To evaluate machine intelligence, we need to understand how our brain processes language. Neuroscience shows that a specific network of regions, mainly in the left frontal and temporal lobes, is responsible for both understanding and producing language. What's fascinating is that this network is modality independent. It activates for spoken language, written text, sign language, even constructed languages like Esperanto or Klingon. That means the brain isn't hard-coded for anyone language, but is tuned to the universal structure of language. This suggests a biological predisposition to linguistic abstraction and combination, combinatorial understanding, which no LMM today possesses by design. Now, here's something surprising. You don't need language to think. While many people equate the two, neuroimaging studies show that tasks involving logic, mathematics, or understanding other people's beliefs, theory of mind, activate completely different parts of brain from those used in language. Also, patients with aphasia who struggle severely with language can still reason logically, solve math problems, or play strategy games like chess. This tells us that language and thought are distinct neural faculties. So when an element demonstrates fluency, it doesn't necessarily imply cognitive depth. A unique trait of human language processing is the seamless integration between syntax and semantics. Unlike all the AI systems that split grammar from meaning, our brains process them together in the same regions. For example, when you hear the red-haired woman is walking the dog, your brain is not only accessing the word meanings but also assigning roles, who is doing what to whom, all in real time. This integration allows us to rapidly understand complex, ambiguous, or novel sentences. It's context-driven and adaptive. LMMs mimic this integration through training but lack the biological unification that makes human language fluid and dynamic. Let's talk about how LMMs actually function. Models like GPT-4 are trained on a simple but powerful objective: predict the next word. Through billions of examples, they internalize statistical regularities of language. Astonishingly, this simple task leads them to learn syntax, semantics, and even some forms of pragmatic reasoning. For instance, they can often complete idioms, infer tone, or match grammatical number without being explicitly told how. In many ways, they mimic aspects of our predictive brain. But here's the catch. They do so without understanding. They don't know what a dog is or what walking feels like. They operate purely on form, not grounded experience. This brings us a fascinating finding. Eve Fedorenko and her team conducted a study where they showed the same linguistic inputs to both human participants and language models. They then compared the activations. Surprisingly, some LMMs, especially those with strong next word prediction performance, exhibited internal activation patterns that closely resembled those of the human brain's language areas. These models weren't built to emulate the brain, but their statistical representations ended up functionally similar. This doesn't prove LMMs are conscious, but it does mean their learning representations align with how we process language. Despite this similarity, LMMs still lack general intelligence. Francois Charlotte argues that LMMs are fundamentally limited because they memorize patterns rather than generalize concepts. For example, rephrasing a math word problem or changing a variable name often cause the model to fail. Likewise, when faced with an unfamiliar cipher, LMMs can't derive the solution from first principles. They memorize outputs but not build internal models of the word. This brittleness reveals their core limitation. They excel at familiar data, not novelty. That's why we can't equate skill with true understanding. So, what is intelligence really? Charlotte proposes that real intelligence is about generalization. It's the ability to solve unfamiliar problems with limited prior exposure. Humans do this all the time. We encounter a new interface or device and figure it out intuitively. Key features of intelligence include fluid reasoning, broad operational scope, and data efficiency. If a system can generalize with minimal data, it is more intelligent. LMMs, by contrast, rely on massive training corpora and often fail when presented with even slightly different formulations. Intelligence is not just the answer, it's how flexibly you arrive at it. To achieve AGI, we need a hybrid approach. Daniel Kahneman described two systems of thinking. System 1 is fast, intuitive, and automatic, like LMMs. System 2 is slow, deliberate, and logical, like human planning and reasoning. Humans fluidly switch between these models. LMMs today are stuck in System 1. They do pattern recognition, but not structured planning. Future AI needs to integrate both rapid linguistic intuition and symbolic causal reasoning. This might involve combining deep learning with symbolic program synthesis or embedding reasoning tools into LMM pipelines. So, what's next? LMMs are not AGI, but they are transformative tools. They can assist, accelerate, and amplify human thinking. Their fluency, adaptability, and scale are remarkable. But to reach human level intelligence, we need models that not only speak well, but think deeply. This requires rethinking of our benchmarks, architectures, and definitions. It's not about building smarter roads. It's about inventing better road builders. Intelligence isn't just producing answers. It's just asking right questions and forging new paths. Right. This is all for today. Thank you.